Next, we have Ewan Reid, who is founder and CEO of Mission Control Space Services. Ewan and I, as well as Susan Jewell, who's on the call today, were teammates in the Mars Desert Research Station, the Mars Society's MDRS. And Ewan is a roboticist from Canada. So Ewan, if you're ready, the floor is yours.
Thanks, Kai. Can you hear me all right?
Yes, we can hear you just fine, and we see you as well.
Great. Yeah, MDRS, that's going back a ways. So thanks for the flashback in history. Let me just share my screen here. Okie dokie. And you let me know if you can see that intro slide.
Yes, we do. Thank you.
Okay. Well, thanks a lot, Kai, for the invitation. It's great to speak here. It's such an interesting, seemingly a diverse group of folks on the call. So that's it's always exciting and already some pretty inspiring, presentations. And it's interesting when you get a big group like this. We're going to see such a range of, I guess, different topics, brought to the table. So, from our perspective, I'll start with a little overview of the company, and I'll take us through this overview deck and focus on a few key elements I think that are relevant to Sam and the folks on the call. To start, I guess, a little bit about Mission Control, the company that I work for and was a founder of back in 2015. We are a space exploration and robotics company, and our focus is on mission operations, onboard autonomy, and AI. So, a lot of buzzwords in there. Really what it means is that we're a software company. We are a company that develops technology to operate and automate robotics and other systems deployed in harsh and remote environments like Mars or the Moon, as well as here on Earth. We're actually a Canadian company, as Kai mentioned, so we're headquartered in Ottawa. We do have an American subsidiary, so and do some work already in the US, some NASA funding and partnerships. So always have avenues to do things both, on this side of the border or your side of the border. I'll tell you, it's a little snowier up here, I think, than it is for most of you. We are, I guess, a 17-person team right now, but hiring. So any folks on the line that are, I guess, particularly software engineers is a big area for us right now. Give us a call. We'd love to hear from you. And I'll go around to the next slide here. In our last, I guess it's 5.5 years we've been around, we have a pretty broad range of experience, but all focused on that area, like I said, of mission operations and kind of robotic control. So there's some logos on the bottom of this slide that provide examples of some of the kind of organizations we've worked with in the past or currently. And there's a bunch of bullets here showing a few different projects. So some of these I have slides for later, and I'll talk about them in a little more detail because I think a few of them will be particularly relevant in terms of a potential collaboration with Sam. What you'll see here is a theme as I go through the deck where I start talking about kind of applications of software that we develop, as well as kind of our core software platform. And so we kind of see ourselves eventually becoming a product company and moving away from these project type engagements and providing a software platform and the applications that sit on it. So you'll kind of pick up that theme as I go through the slides. I won't speak about these bullets specifically here, like I said, because I'm going to move on to go through them in a little more detail, a couple of them. So, that core product really is what we call mission control software. It's a cloud-based system to operate and interact with things deployed far away. And in particular, things that you're trying to work with that are on a network that has very significant latency, like, up to seconds or more, and very limited bandwidth, tens or hundreds of kilobits. So kind of the paradigm of controlling robotics on the cloud here on Earth is flipped on its head when you try to do something as far away as, say, the Moon, where instead of having, a fiber optic cable and all sorts of, and you're worried about, 2 microseconds of delay, you're dealing with many seconds of delay and you're trying to do all this in a really small pipe. And so that requires a different networking architecture and messaging protocol, which we've developed and have used now in over 30 analog space missions here on Earth. So that's kind of the core technology that we develop, linked with another piece, and I'll talk about that in a minute. And those that core software platform we build on with specific applications, which is actually where we get a lot of our business as customers, have a problem they need solved, and we're able to solve it and do it on our own platform as well. We are also in the domain of working on actually flight computers, so embedded systems to go to places like the moon. When we see the paradigm that's emerging of commercial lunar exploration, incentivize public-private partnerships like the Commercial Lunar Payload Service, we see a growing need to have solutions that are off the shelf, let folks that are building a payload and maybe buying a ride from someone, give them a solution that they can work with, so they don't have to reinvent the wheel on each mission, because it's no longer the paradigm of a large prime contractor working on a cost plus contract, for a big government customer. We do support kind of full lifecycle development as well. That's because we are in this paradigm of public-private partnerships. So we work with space agencies and their customers as they plan their missions, even though our end game is really to sell the technology for their use on the mission. And the last two bullets here, in some presentations, I don't focus on them too much, but I think on this particular call, I will. So the first one being the support for analog testing. There's a couple pictures here on this slide that show that we've actually done a lot of this, and we really believe in the value of doing field testing, getting out there and testing engineering systems, making sure that they're designed appropriately for the science that needs to get done, if the science is of course the use case. Breaking things early and often and on Earth before we get farther into space. And so because of that, we've done a lot of this work, and I think that's quite relevant to SAM as an analog site and some of the work that could be done there in the future. And then the last one is our Mission Control Academy program. So in a sense, this is a bit of a departure. I've talked a lot about technology. We are a technology company, but we also are committed to inspiring the next generation to always keep exploring. And this is a program that we've therefore rolled out called Mission Control Academy. It's an immersive technology-based educational experience, lets any classroom with an internet connection operate a real rover deployed at an analog site as if it was on Mars. And so this is something we've done, for now, I guess, 5 years, and we've had students on 4 different continents operate a robot at the Canadian Space Agency Mars Yard. And I think something that's highly relevant to SAM. So I'll talk about this a little bit more on a subsequent slide. I won't go into too much detail on the technology here. I recognize that there's like I said, a very broad range of folks on the call. To some people, they may look at this and say, why did you provide such an oversimplified diagram? And other people may look at this and say, what the heck is this? I fall somewhere in the middle, but I would be happy to take questions later, either offline or during the call. And I'm just kind of talking through while people have a chance to look at this. So if folks are interested, they can kind of get ready with their questions. This also does provide a bit of a graphical picture of what I talked about earlier. There's kind of 3 key elements: the kind of software platform, which is the 2 bold statements in the top and middle on the right, the flight software and the ground software, and then there's the specific applications. And like I said, in the past, we've often got contracts to develop a specific application, like say terrain assessment, and we've done that using our flight software tools and deployed it on our ground software network. I'll skip through this space segment slide. I don't think it's super relevant here. Although, anyone that's interested in this, please feel free to reach out. I think this is a pretty core part of our business and certainly will be moving forward. On the ground segment side, I think there is some relevance here. We like to say that we can provide a service to people that are testing payloads, technologies that they plan to deploy in space before they even are ready to do that. And so rather than have to do a kind of custom implementation for, say, a breadboard and then a field test, and then reinvent the wheel when they go onto their flight model, they could use our system for the breadboard, for the field testing, and have a seamless transition when they actually go on to the space mission. And so this is a model that we've kind of put into work right now. We have, international commercial lunar exploration company customers who are, testing their ground systems. They're not the ground systems. Their breadboard kind of pre-flight, engineering models using our technology, with a plan that as we move forward to the mission in a couple of years, they'll be, transitioning right to the flight mission. And even if there's no plan to transition, so as an example, someone brings a robot or a spectrometer or some payload to SAM and they want to use it, but they don't necessarily want to fly there. They want to sit in their local coffee shop, as the graphic here shows, or maybe just back at their office at their university or wherever they're working. They can interface with that payload using our software, and either on a custom front end that maybe we develop or they have developed using our API, or a generic one if one's available in our kind of library of interfaces. So I have a few slides about applications. I'll talk through one or two of them just to provide some examples of the work we've done in the past. I think we're happy to do this kind of work. This is in a sense our bread and butter in the past, but moving forward will be maybe less so. But there may be some good use cases for something like working with SAM in the sense of using certain specific applications to enable a long series of tests at the location. Most of our work involves robotics, typically mobile robotics, but there's a lot of similarities in different robotic applications and the different sensors that mobile robotics use. And so we're generally quite well versed in vision and particularly machine learning related algorithms. So, change detection and there's lots of kind of applications that could be useful for an analog test. So this video, which I hope is coming through over the network, actually I'll check my network as I do that. Looks okay. Is the demonstration of one of our user interfaces that a customer procured from us for some testing. In this case, at the Canadian Space Agency Mars Yard. It's simply showing a path planning interface for their mobile robot. And they're able to plan a path locally on this global map and then execute the path. And depending on the sensors they have on board, and I don't remember particularly with this customer, it might update in real time with hazard detection and real time adjustments to the path. It may just simply execute the path. Again, I'm not sure on this use case, but this would be an example of the kind of applications that we could develop for our customer or they could develop on our platform. This is a video of some field testing we did in Iceland in 2018. 2019. COVID's kind of throwing all my years off at times like an accordion. So this is not this past summer. It was the summer before, 2019. And it's showing a robot driving around in a terrain that's analogous to Mars. This is actually field testing funded under NASA's P-STAR program to help inform Mars 2020 mission. And what you're seeing in the different colors here is an automated terrain assessment system where it's classifying terrain in terms of its kind of geophysical properties to help inform science operators on the ground and help them make decisions more quickly and make the mission more efficient. And this is another demonstration, shows a slightly different use case. This is actually a demo that we did for Jeff Bezos's Remars conference. And we had a planetary scientist in, I believe it was Las Vegas, operating a robot using this system and is showing the output to the crowd there. And this is a robot up at the CSA Mars Yard. And in this case, the output you were seeing before, the red, yellow, and green was a hazard level. So that was all about navigation safety. So it's kind of a different application, but similar kind of core machine learning algorithm on the back end that's running. This is a new slide for us. It's pretty exciting. It's actually just something that started over the last couple months, but those images that you're seeing on the right, top and bottom, those are both real images of our indoor lunar terrain that we've recently built. And I think they turned out pretty cool. It's a 30 by 20 meter, and I'll let you folks south of the border do your own conversion area that we are using right now to create a data set of not tens of thousands, about 10,000 images to be used to train machine learning algorithms for applications for lunar exploration. But after that particular project is over, the terrain itself is actually reconfigurable. We have both real and fake rocks. We have man-made craters. We have other features, a kind of a rill crater kind of feature. And we can move things around, and we can actually deploy small robots in here and run full end-to-end mission simulations. So we could test payloads, we could test robots in terms of their mobility, but really I think a really big area is actually testing ConOps and actually full mission scenarios. And when you couple this with the software that we develop, what it would mean is that someone could send us a robot, we deploy it here in the moon yard, and someone else is, sitting wherever they are in the world, ideally structured in a realistic scenario with, front and back rooms and different science support, and actually execute a full mission simulation with everything as real as possible, except for the fact that we're not actually on the moon. Another big area that we plan to use this facility for is education and outreach. And so I spoke a little bit about Mission Control Academy, and I'll talk more about it shortly, but we do plan to leverage this facility to deploy missions, to execute missions, and let students in the classroom drive a rover around here as if it was on the moon, and maybe with the right filters, we could make it seem like Mars. It's always a big challenge of which planetary terrain we use, and I guess Sam's overcome that by the fact that Moon and Mars are both M. Good for you. I won't go too much detail on this particular project. It's an ongoing science payload we're developing for the CSA. It leverages machine learning to do autonomous terrain assessment to increase the safety and efficiency of short duration commercial lunar missions that are intended to only last a day. Feel free to reach out independently if you have more questions. There's also some information online. I'll talk shortly about this slide. We are working with a group called Axiom Research Lab, formerly Team Indus, one of the Google Lunar X Prize competitors, who have developed the rover that you see on the bottom right there. They will be sending us that rover in March 29th, I believe it arrives. And in the summer, in June, they will be operating it remotely in a full end-to-end test campaign using some of our AI and autonomy capabilities integrated onto their rover to execute a full mission. So this is really exciting for us. It's kind of the first instance of our business model of deploying a robot at our facility and using our software to do that, coming to fruition. And particularly exciting because we would hope that this becomes the first step towards an actual mission to the moon with that partner in a few years.
2 minute warning, Ewan.
Thanks, Guy. I hope I'm not speaking too fast already. I won't talk too much about this slide. There's a lot of stuff out in social media and other places about this. It's work with a bunch of folks in the US. It's been a great research project, and I think is relevant to SAM because it's really focused around analog testing and the deployment of mobile robotics, and actually a drone in this case as well. So I think I've basically covered this slide as well. I've talked about different analog campaigns we've done, operation from 4 continents. I am proud to show that, a few of the use cases in these little moving graphics are students, because those are examples of a Mission Control Academy program. It's also worth noting that at least one of those images might have been taken by Kai. So thanks for that, Kai. I'd love to see those kind of come back. I know he was with us in White Sands on one of our missions. And now I'll use the last minute I have, I think, to focus on this slide, Mission Control Academy. So this is a program that we started to run because we found ourselves outside day after day operating robots in space-like environments and thought to ourselves, this is really cool. And we're all really inspired by this. And it's a great way to let students learn and be inspired to stay in school as well. And so we started a program where we would let students operate this robot and taught them about mission operations at the same time. And it's grown pretty significantly since then. The experience actually lets them first learn about planetary science, learn about robotics, and learn about mission operations. And then they use tools that we've developed to actually configure and design their own robot. Now, in reality, it's one robot with a bunch of sensors, but they're able to kind of pick and choose a subset of those based on mass, power, volume, and bandwidth constraints. And then they design their own mission and actually execute it, remotely from their classroom. And I think this is something that we are really proud of, want to keep rolling out and have more students do it. We'd love to see tens of thousands of students do this program a year. We're really only limited by the fact that we don't have much of a budget to spend on that. And this is not something we do to make money. It's something we do to test our technology and kind of give back to the community. And so in that sense, we are happy to kind of license this out, so to speak, let other people do this, use this technology and use our model to do similar activities. So, I'd love to see a scenario in the future where there's a robot at SAM and there are students, all around the world or all around the US or whatever, getting a chance to participate in SAM and some of the real science that would happen there and real technology development by operating that robot remotely in the context of their own education. And, whenever I do this slide to people, I get 15 other good ideas from the folks on the call. So, you know, if this is something that sounds exciting to you, you know, please reach out. We're always looking for partnerships, way to deploy this further, and you know, different avenues to expand it. So that's, I think, it. I hope I was under 15, Kai, and sorry everyone for speaking so quickly.
No, it's fine. Thank you, Ewan. Thank you so much. And I will close this just by saying that I was a participant in one of Ewan's, one of these missions when I was at the International Space University. It was intense. It was realistic. Even seeing that aerial view of the Canadian Mars Yard, I still got chills again. I remember where we drove the rover and how we almost fell off the edge. And it was an incredible experience. I can't wait to bring this to Sam. Thank you so much.